Assalamualaikum warahmatullah. We continue with chapter 4 for this module, and this is about the demand side of equilibrium again. But this time we want to look at the, not only the equilibrium in the form of aggregate expenditure equals to output, but we want to expand it further by looking at income and interest rate. So that means we want to find equilibrium income and interest rate as well. Okay, on the demand side of equilibrium. Now, before I proceed further, why it is called demand side of equilibrium? Because all of the analysis here, we use expenditure approach to come up with the results. But we can also use leakage and injection approach anyway. But the main thing here, it is called demand side equilibrium because we look at the demand side. And the demand side we know could be consumption, could be investment, could be government spending. So these are the players on the demand side. Okay, now if we open it up to international interest rate, then the demand side will be added with another, variable, which is net export, that consists of export minus import. So we want to look at the demand side. So this is basically the approach of Keynesian that you have learned in the intermediate macro undergraduate level. So when we want to find equilibrium, if you can recall back the method that we used previously in the previous chapter, so we have income here, we have, aggregate expenditure component here, and we did find equilibrium, let's say like this, AE, and then we have equilibrium income here, and AEE here is equivalent to YE here, and if we have leakage injection approach, it also yields the same results. So S plus tau, and then here I plus G. If we look at this kind of equilibrium analysis, we only know the level of equilibrium output, but we don't know the level of equilibrium interest rate. So now, what we can do in this analysis is we want to look at the equilibrium not only income, but also for interest rate. That means in the previous analysis and the previous chapters, what happens to interest rate? Interest rate is assumed to be exogenous and it doesn't move with any, variables in the system here. All right, so for chapter 4, we relax this assumption. So let's crack on. Now, again, we want to determine national income, which is Y, real income. And this time, we want to look at the interest rate. We also want to look at the output. And consequently, if we know what happens to output, we know what happens to employment. At the same time, we also want to reach to price level after we analyze ISLM, because from ISLM, we can get what we call aggregate demand. Okay. Now, again, remember this equilibrium analysis here, we want to look at the demand side, because all of the equilibrium that we want to find here is based on the demand side, not based on the factor of production side or supply side. Okay, so that's why it's called demand side equilibrium. We already know that expenditure approach is given by expression 1, and injection leakage approach is given by expression 2. So this is nothing new for us. And in the form of graph, I can redraw it again, in the form of graph. In fact, I have did it here, and I redraw it again here. So we have aggregate expenditure component, and we have this AE equals to C plus I plus G. Okay, and then if we use aggregate expenditure approach, as long as it hits the curve AE hits 45-degree line, then we can always find equilibrium income. So label this as Y. Okay, and like I said earlier, you can have AE equilibrium here, and if we use leakage injection approach, so we can have this as plus tau, here I plus G. Alright, so you can see A here and A prime here. Both of them yield the same amount of equilibrium output. But like I said earlier, this kind of analysis using this approach doesn't show us what happens to interest rate. So we want to see what happens to interest rate. Okay, now in order to find equilibrium here, because we want to look at the demand side, so like I said, when we are facing this kind of thing, yeah, just this. Also, of course, at the same time, we may use this also. Okay, so equilibrium, as you can see from previous analysis, it can also change. Okay, let me use different pen. How it works, for instance, if let's say AE changes because increase in I, for instance, yeah. So because I is a direct component of AE, sorry. So AE shift to the right from AE to AE prime such that AE prime equals to C plus I prime plus G. So in this case, I prime is greater than I, just to signify or to tell everybody that increase in investment. Now, of course, here if we use the same method, the second method, yeah, then we can have increase in injection curve, I prime plus G, isn't it? So here is the change in I equivalent to I prime minus I, isn't it? So the new equilibrium is here, YE prime. Okay, let me expand further the S plus tau. Oh, the drawing is not correct actually. Let me fix it. Let me fix it first, because otherwise it gives different meaning. Okay, so it should be here actually, yeah, because it needs to hit S plus tau. So the change here is this. Okay, now the drawing is not neat. You can draw neater than mine. My graph here. Okay, so that's what we saw in the previous analysis. And we can see that equilibrium income can change because of any component here, as long as any component here changes. Okay, or any component here changes, or this changes. Okay, now, and why any of components in AE and also leakage here and injection can change? Of course, because of certain determinants or factors, isn't it? So it's your task to know those factors, yeah, because those factors can actually affect the determinants of equilibrium income when we also allow interest rate in the analysis to change. Okay, so and another thing about the determinants here is that in this new analysis in chapter 4, if you know the determinants, then you need to determine whether that determinants or factor can actually affect, the change in the curve, or it's just, the movement along the curve. So this is a basic thing that you have learned in your principle of macro and micro in your undergraduate level. Yeah, so we call back all of this thing because all of this basic information and also knowledge, if you don't, master it, you're gonna have a lot of problem when you study at the higher level, especially at this master level. All right, now. So we want to look again. Remember, we want to look at the income and interest rate and this demand side equilibrium. So we need to learn the component one by one. So this is what I mean. Okay, because we want to see the change in income and also interest rate, we'll need to know interest rate can affect which bit of demand side. So recall back C, I, and G. For simplicity, for the starting point, if you could recall back in your undergraduate level of study or first degree level, interest rate directly affect investment demand. This one. Okay. So interest rate here can affect investment demand. How it affects? Remember, interest rate is actually at the macro level. We have a lot of investors in an economy or a country. Some of them have enough capital to start their business. Some of them don't. But when it comes to huge investment, no matter how rich you are, when it comes to huge investment, you as investor also need to borrow from the capital provider. So when they lend you money, they charge interest, conventionally speaking, in it. Alright? So in this case, you have to pay them back. In order to pay them back, you have to make sure that you can get some profit or a lot of profit in your investment. Okay? Now, can you see? In this case, if you can borrow money from, capital provider, you can use that money to invest. Same goes to the whole aggregate investor in the country. So what we can say here is that when we talk about interest rate is something that investor has to pay back to the lender, isn't it, of capital. Then interest rate to them is what? Is the cost of borrowing. The cost of borrowing is actually the cost that they have to incur when they want to borrow money to produce goods and services in a country, or to produce product, or to produce output. As a consequence, interest rate here is actually the cost of production, isn't it? Now, if it is the cost of production, if interest rate is higher, would you love to borrow more if you are an investor? No, innit? So in this case, you can see if you can't borrow because interest rate is high, that means the cost of borrowing is high. But that also means the cost of production is high. So your intention to invest is somehow, reduced. So what we can see here is that relationship between investment demand and also interest rate is basically inverse relationship. In other words, if we try to show it in the form of maths, delta I over delta R is negative or less than 0. Alright? And if we try to put it in the form of graph, so we have interest rate here as the price of investment, and we have investment demand here, the quantity. Therefore, it has negative relationship between interest rate and investment demand. Alright? Now here, what's the use of this relationship in our, sage of equilibrium income and interest rate? If you can recall back the previous method, A equals to Y, like I said earlier, using this kind of equilibrium analysis, we only know equilibrium income, but we don't know what happens to equilibrium interest rate. Okay, and we know that by the virtue of this explanation, there is inverse relationship between interest rate and investment demand. And because we want to look at we want to determine the equilibrium income and also interest rate, therefore we need to introduce interest rate into our model. Otherwise, we can never figure out what happens to equilibrium interest rate. And to introduce interest rate in our model here, then we know that interest rate affect one component of aggregate demand or aggregate expenditure, aggregate expenditure, which is investment. Alright, so here we have AA equal to C as a function of disposable income, remember, and then we have G exogenous, and then we have I as a function of interest rate. Alright, so from here, in equilibrium, it is equals to real output. So what I'm going to analyze here is only the first segment of the analysis of equilibrium income and interest rate, which is, IS schedule or curve. So actually, in the equilibrium analysis of income and also interest rate, we are going to use ISLM model. In ISLM model, we have IS schedule or curve. We also have LM schedule or curve. Now we are trying to look at them, each of them one by one, and then we combine both of these two schedules to find equilibrium income and interest rate. Alright, now, so let's continue with our investment demand. Until and years here. All of these, you deflate it to get the present value, okay, present discounted value. And this cost of investment here is not referring to this interest rate. Of course, you have raw materials you have to buy, and then you have, plant that you have to pay the rent and whatnot. So this is what it means by this cost. So this is cost of project. And R here is actually net income or return. Small letter r refers to interest rate. Now, what's the opposite of PDV? The opposite of PDV here is future value, isn't it? Okay, so what's the formula of future value? All these things are not something new to you, and please try to recall back this lesson, try to revise it again. If you look at the example here, this is one way to revise. For a given R, in this case 10%, small letter r means interest rate, the better the project, isn't it? Because what we can understand is that you want to get more income, you must make sure interest rate higher so that your interest return in the future will be higher, so that the higher will be the PDV. Okay, because better project gives better payoff. So look at this example. Try to calculate PDV of 120. And the number of years in the investment is 2 years. Okay, and after that, don't forget, do you know how to interpret the result? You can interpret the result. Another thing that we want to see is any investor in a country or in a market can rank the projects according to the PDV, the present discounted values. So we can try to analyze this using graph. So we have investment opportunity graph here, or curve. So we have present discounted value here, and we have investment at time t. Alright, investment opportunity curves behaves like PPC that you learn. You remember PPC or PPF you learn in the undergraduate level? So because it is similar in terms of the look, then it looks like this, isn't it? So let's say I pick one point here. Then I call it point A. At point A, investment is at this P1, and the present value here is PV1. Let's say I pick point B, P2, and the present value here is PV2. And I have another point PC. So at point C, then the present value is 3. Now, if we have interest rate falling down from, let's say, R1 to R0, what will happen? In this graph, we don't have interest rate. So in this graph, it means interest rate is the determinant for investment opportunity curve. Okay. So if you can recall back, present value or present discounted value is actually close to 1 plus R. Increase in interest rate, decrease in present value, and vice versa. So in our case here, obviously present discounted value will increase. Here, I want to emphasize at investment opportunity cost 1, opportunity curve, yeah? 1, not cost. Here we have interest rate R0. Not R0, R1, yeah, sorry. R1, otherwise you get confused with this explanation. I did explain this earlier. This should be R1. So here, R0. So that means, let me repeat once again. When interest rate falls down from R1 to R0, such that R1 is more than R0, then we know that present discounted value increases. Okay, so the curve shifts outward. But like I said earlier, if you look at the investment opportunity cost curve, investment opportunity curve, it behaves like PPC. From point A, B, and C is movement along the curve. It has negative relationship between PV and also investment amount. Can you figure out why we have this, negative relationship? And can you figure out the economic intuition of this shift to the right in IOC curve? Figure it out, yeah? So you have two things that you need to figure out. So you shouldn't ask me this question in Q&A, because I want you to figure it out. This is number 1. This is number 2 that you need to figure out yourself. Alright? Now, so here, let me recall again. In equilibrium, income must be equivalent to expenditure. Specifically, real income here is equivalent to consumption that depends on disposable income plus investment that depends on R plus government spending, which is exogenous. Because we have Y and we also have R, so these are sufficient enough for us to derive IS curve or schedule. So you want to derive IS curve or schedule. However, before we derive IS curve or schedule, let's recall back our investment demand. Investment demand is drawn with R against investment demand quantity here, and then it is downsloping. So if we have R0 here, then we have I0 at point A. When interest rate falls down from R0 to R1, so we can say investment demand increases because the reduction in cost of production at macro level leads to more investment demand, isn't it? Then they are motivated to produce more, they want to borrow more, so they produce more, hire more labor, right? Now, how to derive IS curve? What do we need in order to derive IS curve? There are two methods basically. The first method is using graph. The second method is using maths, mathematical derivation. The first method here is actually your first degree or your undergraduate level methods. For your current level, you use maths. But let's revise using graph. So we can derive IS curve or schedule using two approaches in the form of graph. Either you want to use aggregate expenditure approach, you want to use injection equals leakage. Remember, both of them should yield the same results, isn't it? Let's use second approach here to show the derivation of IS curve using graph. So in the first frame of diagram, we have S plus tau and also I plus G. Here we have real output. And let's say initial situation is this. So investment at current level of interest rate plus G, and we have saving plus tau. And of course, current equilibrium is here, call it point A. Equilibrium income is YE. Okay. Now, in the second graph is the graph where we have IS curve or schedule. The first graph here refers to leakage and injection. Okay. So, on the vertical axis is interest rate, real interest rate. On the horizontal axis is real output. With current level of equilibrium at point A, in the corresponding IS curve that we want to draw, we want to derive, YE is here. And let's say R0 is here. So let's call this first point, point A prime. To draw a graph, we need at least 2 points. If we have one point like this, then we don't know how to join and get the graph, isn't it? Okay. So initial situation, equilibrium at A. Investment demand is this. Government spending is this. Saving is this. Tau is this. Tax. And interest rate is R0. Let's say R0 increases, interest rate increases to R1 such that R1 is more than R0. What would happen? Go back to this. If interest rate increases higher than R0, let's say here, you can see investment demand decreases, isn't it? So we can look what will be affected, injection curve. Because we can see in injection curve, there is investment demand affected by interest rate. So what will happen? What will happen here is that injection curve will shift downward from IR0 plus G to IR1 plus G. And reduction in investment here is actually the change in investment equivalent to IR0 minus IR1, isn't it? Where is the new equilibrium? At the intersection between new injection curve and also existing leakage curve. Equilibrium income is here, therefore, in the second, the corresponding graph, which is IS curve derivation here, we have YE red, put it prime. And we know that R1 is higher than R0, so R1 is here, YE is here. So this is the point. Now call this point point B, and here B prime. So we have 2 points already. We join the 2 points. We get IS curve. Alright. So we have derived IS curve. That's how we derive it. Now, if you can recall back what you have learned in your undergraduate level of macroeconomics, especially intermediate macroeconomics, what does it mean by IS curve? You look here, let me use different color. You look here, this is equilibrium, isn't it? Equilibrium says that whatever being produced is equal to whatever being spent. Also, leakage equal to injection. That means if we look at expenditure approach, why whatever being produced is equal to whatever being spent. So, along IS curve here, as you can see, point A prime is derived from point A, the first equilibrium in expenditure approach in the product market. The second equilibrium here, which is B prime, is derived from point B in the first graph, isn't it? So you can see all of the points along IS curve are derived from equilibrium in product market. Why I say equilibrium product market? Because at point A and B, this whole, whatever being produced is equal to whatever being spent, and this is equilibrium in product market using expenditure approach, and this is leakage approach. So what does it mean by IS schedule or curve? As you can see, IS curve here shows you all possible combination along the curve of IS, in which combination of interest rate and income, let's say A prime here combination of R0 and YE, shows you equilibrium in product market at point A here, okay, and B prime here is a combination of R1 interest rate and YE prime output when output market is in equilibrium at point B in the first graph. So IS curve or schedule shows us combinations of all possible interest rate and output when product market is in equilibrium. So IS curve is for equilibrium in the product market. Now, the relationship shows in IS here is between output and interest rate. So, if interest rate falls down, output increases. Why? Because investment increases due to decreasing cost of production, which is interest rate, isn't it? Since investment is a direct component of aggregate expenditure, so aggregate expenditure here increases, isn't it? Now we have imbalance here because this right hand side is more than this now. So what should be done? Adjustment take place, output will increase. When investment increases, okay, production will increase after the decrease in interest rate. Then hire more labor can produce more, and therefore on the left hand side here output increases until both of the sides are equal and reach to the new equilibrium. Alright, now so that means any change in interest rate here, if it decrease, leads to increase in equilibrium output and vice versa. That means we are talking about movement along the IS curve. So when interest rate is the reason of any change in the component of IS, yeah, and component of IS is this, yeah, and then we are talking about movement along the curve. What if we have other things? Can other things other than interest rate affect IS curve? Will it be movement along the curve or what? Can IS curve shift to the right or shift to the left? What are the determinants of shift to the right or shift to the left in IS curve? Again, we know that the components of IS curve consist of this, C, I, and G. Investment is being affected by interest rate leads to movement along IS curve, isn't it? But any other factors other than interest rate can affect investment. Any factors can affect consumption. Any factors can affect G other than interest rate. Can you figure out if these factors can affect either one of these, what would happen to IS? Can you figure out what will happen to IS in the form of graph? Alright, so these all are basic of undergraduate level of study. So let me repeat once again what you need to know about IS schedular curve here. You need to know how to derive in the form of graph. you need to know, once you derive it, what does it mean by IS curve. You need to know how R affect IS curve using economic intuition and explain the graph. You also need to know what are the other factors that can affect IS and what will happen to IS if other factors affect it. Show it in the form of graph. So all of these are basic, yeah? Next. So we want to look at second method, which is mathematical expression of IS. Of course, before I can show the expression of IS in mathematical form, I need to derive it. Okay. So let's use a plain whiteboard here. We know that in equilibrium, real output equals to C plus I plus J. And then call this equation 1. And given that investment is a function of interest rate, and given that by theory, investment and interest rate is actually negatively related, we can rewrite 1 as the following. So we have y equals to, c y minus tau as a function of 1 plus I as a function of r plus g. And let me put some other information here. Yeah? So C is actually as a function of disposable income, call this one A. Alright. And then G is what? Of course, government spending. Okay. Now, I need to add something here. Let me use different pen. And otherwise it is incomplete in terms of explanation. And 1A, we can rewrite 1 as the following and call it 2. Remember, we want to derive in the form of maths IS curve, in particular the relationship between R and Y, yeah? In particular the relationship between I and R. And basically in this case, let me make it clearer. Yeah? Instead of derive IS curve, because IS curve actually is given by this in generic form. As long as you have R, that's it. Okay, but you can rearrange it further if you have specific alphabet for the constant or the intercept. But here we cannot derive it further because this is very generic, very general. Okay, so that's why we stop here. But for instance, if I give you this, y equals to a plus b y, okay, minus tau y, for instance, plus ir plus g. And we assume that this one is equal to 0. So y equals to a plus by plus I specified it as, let's say, I make it even more specific and not very general, not very generic. So I here I specify it as I naught plus b not B, it's not proper B, because we already have B, plus CR, the coefficient of, interest rate here, plus G. If you rearrange it, then you can get IS relation or curve or schedule. Why? Because IS relation shows you what? Y as a function of R or R as a function of Y. So you can rearrange this such that only Y on the left hand side and the rest of alphabet on the right hand side. That one is possible. Why? Because consumption function has been specified further and investment function has been specified further. That's why you can do it. However, class, if you are given 2 here, then it stop here. So you cannot specify further your IS function. So I hope this is clear, yeah? Because that's where mathematics here shows you need to know some theory to decide the sign of every alphabet. Alright, now let's go back to our objective. So we stop there for derivation of IS curve because it is a generic function. Alright. So here, what do we need to do with 2 here is that to see the relationship between income, real income, and interest rate. What kind of relationship? In the form of graph, we have seen that here IS is relatively related in terms of income and interest rate in negative way. How do we prove it mathematically? Okay, let's move back to equation 2. What we need to do with equation 2 is to take total differentiation of 2. Take total differentiation of 2. We do this. dy equals to delta c over delta y in bracket dy minus delta tau over delta y dt plus. Now how to totally differentiate investment function here? Delta I over delta R dr. Can you see? Because investment is a function of R, partially differentiate investment with respect to R, and then totally differentiate R because we don't do partial differentiation of R because R now is exogenous. It doesn't depend on anything else in the system or in the equation. What about G? G is also exogenous. It doesn't depend on any other variable in the system or this equation too. So we use D instead of delta. Is it clear? So call this one equation 3. Now, when we want to see the relationship between R and also between Y, we need to take one assumption here. What is that assumption? Because we just want to show about the movement along the curve, isn't it? R and Y from here to here. And that movement is between Y and R. So other things which are not related to Y and R should be considered constant, isn't it? So what is it? No change in government spending. So we have to assume dg equals to 0 because no change in government spending. The change is between income and R. Okay. Now, can you ask yourself, alright, now I have some mistake here. What is the mistake here, mathematically speaking? You look at my mathematical derivation here. The original function is dy, isn't it? Tau as a function of y. So when you differentiate delta t over delta y, and then what is it? This shouldn't be dt. It should be dy. Is it clear? So that's the mistake. What should we do with equation 2? What you need to do with equation 2 is to rearrange them in such a way that you get dr over dy equals to something here. Okay? And the step you must show, I'm not going to show it here because this is just a simple calculus, but when it comes to assignment, also quizzes, yeah, you need to show this step here. How do you get into a final answer between, equation 2 and this final answer? So the missing step here must be shown in your work. Alright, so finally, if you rearrange equation 2 there, such that dr over dy on the left hand side and the rest on the right hand side of equals. So if you rearrange them, then finally you should get expression 5 here. Okay, now if you look at expression 5 here, how do we know that it is a negative? Dr over dy is negative. How do we know? Now recall back, we have 1a, isn't it? That is c equals to or a function of disposable income, and we know that the derivative of c, partial derivative of c with respect to y is positive. If there is an increase in income, consumption will increase, isn't it? Okay, so we know that this one is positive, yeah, by the virtue of this. This one is positive. And this is basically MPC, remember? And MPC is less than 1. Okay, now what about this? We have this tau, isn't it? But if we take partial derivative, it's going to be what? It's going to be positive as well because the collection of tax depends on how much income you have. So if there is an increase in income, the collection of tax will increase, isn't it? So it's positive. But the collection of tax cannot be more than the amount of increase in income, isn't it? Otherwise, nobody wants to work. So that means, okay, this ratio, the results here, though it is positive, it should be less than 1 as well. So you see here, this one is positive. Now, let me erase this. This is a mess now. So, for the numerator part here, 1 minus value less than 1, isn't it? So, the whole numerators are positive. Alright, what about denominator? We know that investment is a function of interest rate, and we know that the relationship between investment and interest rate is negative or less than 0. So this one is negative. Positive means negative, negative or less than 0. So what does it mean? dr over dy is negative. That's why the IS curve is down sloping. Now let me ask you, this one is what to the IS curve? Mathematically speaking, it is the slope of IS curve. But how do you interpret this result? How do you interpret it? You should know how to interpret it. So that means, if you look here, yeah, if it is talking about the slope, let's say we are here, R naught, Y naught, and we move to point B, then we are talking about this, isn't it? The movement from A to B, the movement along IS curve. Is this similar to the shift in the S-curve? Okay. What happens if we go back to this initial equation here? What happens to income? Instead of R changes, G changes, C changes. Can we see that its movement along the IS curve also? Alright, so we are talking about the shift in IS curve. We need to know what's the factors could shift the IS curve from to the left or to the right. So if there is a change in R, is it, can we call it as a shift in IS curve? Yes or no? So these are the basic things that you have learned during undergraduate that you need to recall back and relate it with what I'm talking here for this mathematical derivation. Alright, so we have done the first part of analysis, which is IS analysis. Now we want to move to the second curve or schedule or relation, that is LM curve. Once we are done with LM curve, then we combine both of them to find equilibrium income and also interest rate. Remember, IS curve shows you all possible R, interest rate, and also income, okay, in which along this IS curve, product market is in equilibrium. When we say equilibrium, Y equals to C plus I plus G, isn't it? Okay, alright, so we crack on. We move to derivation of the LM curve. The derivation of LM curve is not talking about product market. LM curve talks about money market. Okay, so if it is about money market itself, you have demand and supply. So that means we have money demand, we also have money supply. Alright? Okay, now because we have these two things, so we learn these two things separately and then we combine both of them to derive LM curve or schedule or relation. Alright, now let's talk about money demand first. Now if you can recall back what you have learned in your first degree or undergraduate level, then in general money demand for money can be classified into two categories. Okay, but before we talk about money here, we talk about wealth. Wealth can be in the form of asset, can be in the form of money, can be an asset can be in the form of financial asset or other types of assets such as houses and whatnot. Now, another question here is that if it is about financial, instrument or financial assets, can we also consider money as financial asset? Definitely, yes. Because when we talk about financial asset welfare in the form of financial assets, we have, other financial asset, and then we have money. Now let's say for simplicity, we have, all other types of financial asset considered as bond. Now let me erase the mess here. So what's the difference between bond and money here? If we keep our wealth in the form of bond, we will earn interest return. However, if we decide to keep it in the form of money cash, okay, no return, or return is zero. So whenever interest rate increases, it gives motivation for individuals to keep wealth in the form of bonds to reduce the amount of money kept as an asset, and vice versa. In fact, if you can remember, this has something to do with the price of bond also. When the interest rate increases and price of bond decreases, may as well buy bond, isn't it? Because this gives you a lot of income compared to keeping money. But bond here, in comparison with money, has higher risk because interest rate and price keeps changing. So whenever you want to cash your bond because you have some emergency to use money, and so sudden that the price of bond decreases, so the value of bonds decreases and your return in terms of sales is decreasing, or perhaps interest rate because keeps fluctuating, then the return is also unstable in it. But the money return, okay, because we don't put it in a speculative way like the way we keep bond, like the way we play around with bond, so it is less risky, but of course no return. So this kind of thing, the way we keep bond and money in this kind of method shows the behavior of our behavior in terms of demanding money as an asset. Okay, as then this kind of money demand is what we call speculative money demand or speculative demand for money. And the speculative demand for money is denoted as L. L is a function of R. So the relationship between speculative demand for money and also interest rate is negative, isn't it? Because if interest rate increases, your demand for money as a speculative one will decrease. All right. I love to make mess here. All right, now let me erase this. So that's the first type of, category of money demand. Now let's move to the second type. The second type is the one that we always have, that we always demand. So it's called transaction or precautionary demand for money. You need money because you need to do transaction, buying and selling. So usually people demand more money when they have more income. If you don't have income, you don't demand money. How? Because you don't have anything to buy in it to do transaction. So in this case, transaction or precautionary demand for money is denoted as small letter k, okay, as a function of income. And the higher the income, the higher the demand for money for transaction. So it has positive relationship. So when we combine both 1 and 2, this is a typo, yeah? When we combine both 1 and 2, then we get the total demand for money. We have a real demand for money, call it M, where M is this. Real demand for money, if we try to rewrite it in another way, it is basically nominal demand for money divided by price level. So expression 8 shows us the real demand for money. Let's try to summarize all of this. So we put it in this way. So we have generic form of money demand here, and money demand depends on real interest rate and also output. And another way of writing money demand is this: nominal money divided by price level. Now, we know that the components of money demand is basically speculative demand for money, and also transaction demand for money. So when we differentiate money demand with respect to interest rate, it is negative because of this. Here we don't have R, isn't it? But if we differentiate it with respect to income, it is positive because of this transaction demand for money. We want to put it in the form of graph, yeah? So we write real interest rate here and quantity of money here. We know that the transaction demand for money depends on income and not on interest rate. But the graph here shows you interest rate. So how does it look like? Because transaction demand for money does not depend on interest rate, but we want to put it in this graph in which we have real interest rate and also quantity of money. That means regardless the level of interest rate, the quantity, transaction, demand for money is always the same, isn't it? Okay, so let's say it's here. T, I call it MT. So regardless the level of interest rate, transaction money demand is always vertical like this. Alright? So this transaction money demand. And what about the speculative money demand? At speculative money demand, okay, or speculative demand for money to this graph. And remember, the relationship between speculative demand for money and interest rate is negative or less than zero. That means the speculative money demand should be downsloping, isn't it? But if we add this, then for every interest rate, we have to shift it to the right by this much, isn't it? That is this distance, isn't it? So it means we have to start from here, because this is the distance of transaction demand, and start from here is the distance for speculative money demand. So it should look like this. So this is our MD, the real money demand. And I can clear these things and clear these things so that I get the total money demand. So here, for total real money demand, if there is a change in R, what happens to money demand? Would it shift or not? What factors that lead to the shift in money demand? Please go back to the basic of principles of macro, yeah? Next, we move to the supply of money, and the real supply of money is this fixed nominal money supply and also price level. And it is fixed because we cannot determine it. It is determined by the central bank. And can you see it does not depend on the interest rate? So if we try to draw it, so we have interest rate on the vertical axis and money, and then it becomes this, okay, real money supply. We label this level of money supply as this, and we combine it with real money demand to obtain equilibrium in money market. So this is the equilibrium interest rate, and this is equilibrium money in the money market. Alright, we're gonna use this equilibrium position to derive LM curve or schedule or relation. So let's move to these two frames of diagram. We combine both money demand and money supply in a system, yeah, to find the equilibrium in money market. And then after that, we derive LM curve. So let's say we have money market here, money supply here, the real one, money demand here, the real one, initial interest rate, initial income, so this is MS1. Let us be more specific. We label this MS1 as M P naught. Let's change it. Instead of 1, we put it not here, yeah? Alright, so this is point A. So in the second graph, we want to put the LM curve. So we have R and Y. So we have R naught with Y naught. I rewrite again Y naught here so that you can see in your screen. So point A in the first graph here correspond to point A prime here with R0 interest rate and Y0 income. Okay, now we want to have another point. We need to have another point so that we can join these 2 points to get LM curve. Alright, so what should we do? Let's say money demand increases because income increases. So income increases from Y0 to Y1. Money demand increases means it shifts to the right. Okay, so from MD to MD prime. Alright, so we have now Y1, and what happens here? Interest rate now increases, okay, to R1. So this one becomes R1. Alright, so let's call this new equilibrium in the money market point B. And R1, as you can see clearly, is higher than R0. Y1 is higher than Y0. So Y1 should be here. R1 should be here, isn't it? So the point should be here, point B prime, A prime. So join the 2 points. Let me fix it. Join these 2 points. Then you get your LM schedule with current nominal money supply and current price P0. Okay, so as you can see here, after the derivation, the curve is upsloping. Can we have shift in LM to the right or to the left? Can you figure out the determinants or factors that could lead to the shift in LM? Could it be increase in money supply? But what makes money supply increases? If we talk about the shift in LM, can we say that it is because of the change in R or the change in Y? Can we say that? Can you figure out all of this? Because this is the main basic of LM that you must understand and you already learned in the first degree. Alright? Now, we have done the first method. Remember, if we want to derive IS or LM, we have graph methods. And here we have money market, reserve, and M curve. So we have done that. Now we want to look at the mathematical methods. So for the mathematical method, we know that for LM, the concept is it shows all combinations of real interest rate and income in which money market is in equilibrium. So that means point A prime here is equilibrium in money market, which is at point A here. Point B prime here is equilibrium in money market at point B in the first graph, isn't it? So along this point, all combinations of interest rate and income shows us equilibrium in money market. Alright, that means at point A, MD equal to MS. At point B, the new MD equals to the initial MS, isn't it? Mathematically speaking, it can be expressed as expression 11 here. This is the condition. This is the specific or generic form of the condition. So it is an essence of LM curve. And then it is a generic form because the function here you can see you don't know what is the slope and what not. Unless you have very strong basic theory behind it, then you can decide the slope whether it is positive or negative. Alright? So now we need to know the slope of LM. And the slope of LM here, we need to derive it using mathematics. So let me rewrite again the equation. Equation 11. So we have money supply over price, nominal 1, which is fixed. And then as a function of speculative demand for money and also transaction demand for money. This is 11. And as you can see, the left hand side is money supply, the right hand side is money demand. So it is money supply equals to money demand in real term. Okay, before we derive, you must understand the concept of derivation first. If you look at the derivation here, at point A, moving to point B, did you see any change in money supply? Nominal and also real? No change, isn't it? So remember that. What we need to do is to totally differentiate 11. It is totally differentiate real money supply equals to partial derivative of speculative demand for money and also transaction demand for money. Call this one 12. So this one is not minus, yeah? It looks like minus, so it's actually multiplication. The next thing is, remember that when we derive LM curve using graph, we know that there is no change in money supply, isn't it? That means what happens to D M over P not here? It should be set to 0. So set D M over P naught equals to 0, then 12 becomes what? It becomes 0 equals to delta LR over delta R times dr plus delta this one delta y dy. Call this equation 13. What do you need to do next? Rearrange it in such a way that on the left hand side you have dr over dy and the rest on the right hand side, and we're gonna get this 12 for instance, yeah? I don't want to confuse you with the numbering, so let's change the number here, otherwise you get confused. Call this one, change it. Okay, this one 11a, right? Then this one 11b. Then only you can have 12 here. Remember the step between 11b until 12 here, you must show it clearly. Don't just jump the step. I want to see the steps. Alright? Okay. The next thing that we need to know is the slope sign that we get here. Okay, so if you see here, although we have negative sign or minus sign here, can we decide that dr over dy or the slope of LM curve is minus sign? But recall back, the drawing shows that it is upsloping. So then you must decide carefully. If you can remember, we have this and this. This N, which is speculative demand for money as a function of interest rate, is number 6 in the previous slides, and this one number 7 in the previous slides. And we know that for number 6, delta L over delta R is actually what? It's actually negative, isn't it? So negative. And for the second one here, this number 7, expression 7, delta K over delta Y is actually positive. You look at minus sign here, and then delta K, this should be delta. There's a mistake there, typo. This one is positive, and this one is negative. So positive meets negative, positive. Can you see? You have to be very careful in deciding the sign of the slope of LM or any kind of curve. Don't just look at the minus sign here or negative sign here, but look at every single partial derivatives or total derivative found in the equation. Okay, so this shows that it has, we have LM positively related between interest rate and also real income. Okay, but can LM shift? I did ask you this question previously, yes or no? If you say yes, what happens to the slope when LM shift? Increase or decrease? Will it change also when LM shift to the right, to the left? You get what I mean? Yeah, upward, downward. Alright? Now, the next thing is we need to combine both IS and LM to reach to the equilibrium, income, and interest rate. We can use the first phase of diagram here, IS, LM, analysis. So we have interest rate here, we have real income here, and then we have IS here. Okay, and then we have LM here for a given money supply, P naught. Okay, initial interest rate R naught, Y naught. So that's equilibrium at point A. Now, at the same time, here, not only I want to show you equilibrium interest rate and output and equilibrium money market, I also want to show you from ISLM analysis here, we can derive aggregate demand. I'm sure you have heard the term aggregate demand in your bachelor degree study, and because it talks about demand, so it must have price and quantity, isn't it, for micro? But for macro level, we have price level and output level, which is in real term. Also, because it talks about demand, therefore it is downsloping, isn't it? But how to derive it using graph here? So we have initial point where we have real money equals to M over P naught, alright? Interest rate R naught, equilibrium income Y naught, okay? At point A. Now, for aggregate demand curve, in the second graph, we need to have price level on the vertical axis and real output level on the horizontal axis. Because we want to draw it, aggregate demand against price and also output, so we must have initial price, which is P naught, which is given, yeah? So we have initial price P naught. Now, let's say price decreases. What happens next? It may affect which curve, LM or IS? It affects LM because obviously you can see price here. So it affects money market. In money market, equilibrium money market is given by money demand equals to money supply, and it is M over P naught, the current equilibrium, isn't it? So because price decreases here, so P naught decreases to P1. Then what happens next is that you can see money demand equals to money supply at the new point. This is money supply, and M over P1. So what happens to the new money supply? Increases. What happens? Money demand here has to adjust to increase also until they are equal. So we must have new LM, isn't it? Because they both increases to maintain equilibrium in money market. So they increases. That means, okay, shift in LM to LM M over P1. Can you see? So obviously the new equilibrium must be at point B, and adjustment between LM and IS in the ISLM analysis, interest rate falls down to R1. Output, real output increases to Y1. So here, let me clear the mess here, otherwise you cannot see it. So now, initially, we have P naught falls down to P1 such that P1 is less than P naught. We also can see in the first graph, Y naught increases to Y1 such that Y1 is more than Y naught, isn't it? Okay, it's just repetition, yeah? So we have P naught here, Y naught here, and call it A prime correspond to equilibrium at point A in the first graph, ISLM analysis. And then P1 here, Y1 here, point B prime correspond to B in the first graph for the second equilibrium in ISLM analysis. Join the 2 points, we get what we call aggregate demand curve. So aggregate demand curve here shows you downsloping curve of itself. Okay. Now, so as you can see, we can see in addition to these two, we can see interest rate falls down to R1. Now, what's the economic intuition behind all of this? Why it happens like that? When price falls down from P0 to P1, then obviously it affects money market. In money market, it affects money supply directly because money supply, real money supply, is actually this, isn't it? So price falls down, the whole thing here goes up. That means real money supply increases. Because in equilibrium, money demand has to be equal to money supply, this one doesn't hold because this money supply is more than money demand, isn't it? So, in order for both of them has to be equal, money demand has to increase as well until both of them are equal at the new situation. And that new situation is a new equilibrium leads to increase in LM. From LM M over P0 to LM M over P1. This is capital M, yeah, because it shows you nominal money supply. Okay, now after the shift in LM to the right, and because of increase in money supply, intuitively interest rate falls down from R0 to R1. such that R1 is lesser than R0. Now, what does it mean here in the economy? Remember, interest rate is the cost of borrowing for all investors and therefore the cost of production for investors. Now the cost of production for investor is relatively cheaper, so it gives more motivation to investor to invest more. And therefore investment demand increases due to this. Now when investment demand increases due to this, the investors start to produce more in the factory, produce more, needs more employment, labor, so employment increases, and then output increases, labor increases, output increases. So that's why you can see interest rate falls down. Initially, price falls down here from P0 to P1, and then LM shift to the right. Interest rate falls down from R0 to R1, and then output increases from Y0 to Y1, and then we can create the downsloping aggregate demand curve. So basically, I have answered this question or not? No, I haven't. So this is just the reverse of my explanation here. So why don't you try this reverse, see what would happen and how to explain it intuitively. So this question is the reverse of my work here. This is the case of decrease in price. This question is the case of increase in price. All right. So what happens to interest rate and output? So you need to use IS and LM. If you look at this question, do you need to find what happens to the price finally? The final equilibrium price. In this case, I just want to show you the derivation of ED. Can you figure out? Do you need to show all of this also? Okay, what happens to the final price? All right. Now, and here, if you look at the last slide, I also give you one example of exercise that you can do as a revision. And this revision, if you look at the question, it gives you number. And in fact, this question is not master level of question. I put it here for you to revise. All right. So revise it, do it. We have a lot of references that you can refer to when it comes to study, YouTube, notes, on the internet and whatnot. So you have a lot of things that you can utilize to assist you in your revision. So that's all. Thank you very much. Assalamualaikum warahmatullahi